Well, it is time for another lesson. I know you are ready and chomping at the bit. That means you've been horsing around. Let's go ahead and review what we did dealing with graphing of lines and seeing if a point is where the lines intersect, if it's true for both of them, like this example that we did. Determine whether 11, 2 is a solution. Is it true? Is it the intersection where it's true for both? So we put the 11, 2 in. Is 11 minus 2 equals 9? Yes. That's in the x minus y. And then 2x plus y equals 9. Is 24 equal to 9? No. So, therefore, is this a solution to the system? No, it is not a solution. Remember what that meant was that the first line, the x minus y equals 9, 11, 2 is a point on the line. Every time you try it on that line and it works, it's a point on that line. It did not work on the 2x plus y equals 9 line. So 11, 2 was not a point on the second line. And the point at which the first line and the second line meet will be true for both of the equations. So the solution, it is true, means it's the intersection of the two lines. And then here's one that does work. The 6, negative 3, we put it in the same way. 9 equals 9, yes. And does 9 equal 9? Yes. So 6, negative 3 is a solution. Well, that's true. But we can be more specific. Instead of the indefinite, let's use the definite article. It is the solution. As long as we have lines, lines only meet in one point. Remember I mentioned we could have different figures that could meet in more than one point, but as long as we have a straight line, it's going to meet in one point. So that is the solution to those two lines. It is where they meet. So here were the steps on solving a system by graphing. Which is not what we just did, we're going to get to the review on it. You would graph both equations on the same coordinate plane. Identify the solution, which means the coordinates of the point of intersection. And you check that it is in fact the solution by substituting it, the x and the y coordinates, into each equation like we just did. And you should come up with true and true, or yes and yes. Okay, so here's an example that we did. There's the system of y equals negative x minus 2 and y equals x minus 4. So the negative x minus 2 has a slope of negative 1, and of course it has a y-intercept of negative 2, which is 0, negative 2 as far as the point goes. Y equals x minus 4, the slope is 1, and the y-intercept is negative 4. So we use that information to graph our line. Go to the y-intercept, use the slope to move to points, draw the line. When we do that for each of the lines, here's what we get. There's the first line, there's the second line. Where's their point of intersection? Right there at 1, negative 3. Okay, so that's what we have seen on the graph. Now let's check and see if that works. 1, negative 3, put that into the first equation. And yes, negative 3 is minus 1 minus 2. Okay. And then is negative 3 equal to 1 minus 4? Yes. So we have a yes, yes in the equations. Now you might say, well, you're doing it, you're not doing it. We had two different examples. One was just learning to try the point and see. Is that point the point of intersection? Yes or no? And I explained that. You have to get yes, yes. Okay? Intersection, both. All right? Now, the section is labeled solving by graphing. And that means we're going to graph the lines. We're going to look at that graph. It looks like graphs are inaccurate. You could be a little bit off. Even if you use graph paper, you could miscount. Okay, and put the line this way instead of that way. So, oh, that's where I think it is. Okay, now use that technique once you find the point from the graph to try it in the equations and verify it. So what we did at first is really the check. Okay, all right, now let me summarize and kind of group this together. I've already said this to you, but there are really only three possibilities. The first one is what I've talked about. Three possibilities for what? Two lines on a graph. Okay, there's my coordinate system, and I graph two lines. What could happen? Well, the first thing is they meet. Okay, that's going to look like this. They're intersecting lines. Okay, now, number of solutions. What did I tell you already? How many solutions are there? Yeah, there's only one solution. There's the one point that those lines meet at. So what is the answer going to be? A point, or what are the two words we use instead of a point? It's an ordered pair that represents that point. So if the two lines meet, you're going to find the point, the x coordinate, the abscissa, the y coordinate, the ordinate, the ordered pair that shows where the two lines meet. Okay, so that is the first possibility. Now, the second possibility is this. We have parallel lines. Okay, do lines have to meet on the coordinate system? No. Could have this line and that line. Now, if they are parallel, what do they have that is the same? What? The same slope. So you look at the equation of a line and you'll be able to see they have the same slope. Okay, the m. Y equals mx plus b, slope intercept m. Okay, parallel. Okay, what will be different about the line? The slope will be the same, but the y-intercept is different. So when you have equations of a line that in their simplified form are like this, y equals x plus 2, y equals x minus 7, parallel. They were both y equals x, ding, ding, slope of 1. Okay, what does that mean? It means they have the same slant. But plus 2 plus 7, one's 5, if you will, 5 units higher for any x value in the y than the other one is. So they're going to be parallel lines. They're going to stay that distance away. Of course, that's not the perpendicular distance, but we're not worried about that. They're going to stay that same distance away. They're parallel. Okay, so parallel lines. Now, think about it. How many solutions are there? Well, what does it mean to be a solution? I've said this several times. That's where it works on this line and on that line. It's true for this line. It's a point on this line, a point. How many points do they have in common if they're parallel? Bing. Right. So how many solutions are there going to be? None. So what's the answer? The empty set. Okay, so what is that going to look like? I'll show you mathematically later on. Understand that if you come up with no answers, it means parallel lines. Now the last choice is this. You have two lines that are actually the same line. Huh? Okay, you see y equals x plus 4. And then there's another one. It's a rearrangement of that. Maybe it'll be something like 4y equals negative 4x plus 16. That's not the same. Yeah, that's y equals x plus 4. It's in a different form. I multiplied it by 4. I moved the x over, if I did it right, okay, in my head. So they look different, but when you simplify that second one, guess what you get? Y equals x plus 4. So if you just went ahead and graphed the one line, graph the other line, it's the same thing, right? So the two equations can represent the same exact line, okay? How many numbers, how many points, I should say, how many points are going to be on both of the lines if they're the same line? All of them, right? Every single point that's on the one line is on the other line because the other line is the one line. So how many solutions are there going to be? An infinite number of solutions. So what's the answer? All of the points that are on that line. So here's what I'm saying. You know two lines intersect in one point. If they're parallel, you have nothing in common. If they're the same line, you have everything in common. So it's either all or nothing or one. You might have heard it's either all or nothing. Well, it's either all or nothing or one. All, same line. Nothing, parallel lines. 1 point, intersecting lines. Those are three options. All or nothing or one. Okay, let's look at an example of this. Solve the system by graphing. Okay, x plus y equals 3 in slope-intercept. Y equals negative x plus 3. And here's 2y equals negative 2x plus 6. If I divide by 2, guess what I get? Y equals negative x plus 3. Hey, that's what you just finished talking about. That's the same line. What a coinkydinky. Huh? What a coincidence. Do you ever walk in somewhere and you have on, of course, you know, studio friendly, wearing solid colors and that. You have on the same color shirt as someone. You go, what a coincidence. I didn't get that, whatever, green shirt memo. I tease about that. There's some people, sometimes it seems like, you know, 2 or 3 people in the building wear the same color shirt. What a coincidence. What does that mean? It means we wore the same thing. Same. Coincidence. Okay, take that and change the form to coincide. The lines coincide. They are the same line. That's the term that is used. These lines coincide. They are the same line. So that means when I graph them, you have the blue and the green. It's going to look, there's the green, the blue, and there's the green over top of it. They're the same line. So what's the solution? The line. That's what you write. You say the solution is the line. Y equals negative x plus 3. Okay, here's a second example. We have y equals negative x plus 3 and y equals negative x plus 7. You should realize what I said a few minutes ago about that. They have the same slope and different y-intercepts. This is up 3, this is up 7. Both of them have a slope of negative 1. So when I graph it, there's the one with an intercept of plus 3, there's with plus 7, and they both have a negative 1 slope. So they are parallel lines. What is the solution? Where do they touch? What do they have in common? Where do they coincide, if you will? Never. So the solution is the empty set. So now you've seen all three possibilities. We've looked at intersecting. It's a point. Coincide, it's the same equation of a line. The answer is the equation of the line. Parallel, same slope, different intercept. That means empty set, nothing, no points in common. All or none, or one. Okay, let's look at a real-life example. Drew is considering two options for financing a used car. The loan from Bank A requires $3,000 down and $250 a month. The loan from Bank B has the same interest rate but requires $2,000 down and $350 a month. Write a function rule to describe each financing option. Then graph the system to find when Drew will have spent the same amount of money. So we're going to make an equation that we'll put them on the graph and see where they meet. Equation for each bank. Wherever they meet, that will be the point where the money he is spending is the same at that x and y. Okay, now what equation do we make out of that? Well, you have something that's a constant and something that changes depending upon this. What? The down is the constant, and the how many months, that's, money per month. Okay, that money per month is our mx. Okay, because you put an x in and the amount per month stays the same. Okay, like $250 a month, $350 a month. Can you see that? The constant is our b. It's down payment. You have to put that in at the beginning. Okay, so understanding that, here's the two equations we write. Bank A, it's $250 a month. $3,000 down. Bank B, $350 a month with $2,000 down. Now, you can graph that. What I would suggest is on the y-axis. Now, you'll see it with the thousands, but you could just make it 1, 2, 3, 4, and then this way put THOU as thousands, so you remember the units, okay? But we had room, so we wrote those in there. Here's what it looks like. Okay, there's our line for B, blue line, bank B, 350x plus 2,000. Here's the line for bank A, started at 3,000, and you see it has a lower slope. That's the 250x. And there is where they meet. And that's at the point 10, 5,500. So what that's telling us is after 10 months, Drew will have spent $5,500 on either loan. Now you can see at any particular point, like 2 months, 4 months, 6 months, I go up to the blue line first, so that means less money. But at 10 months, they're equal, and after 10 months, the blue line is ahead. The green line is the first one I'm going to go to, less money. So that's telling you that if you're going to pay the loan back in 6 months, then you should go with the blue line, with Bank B. But if you're going to be 2 years to pay it off, then Bank A will end up being less money to pay back. Okay, so that's an example of using, of course, I know we're just doing lines and there's a lot more to it in real life, okay, but it's the idea of using it to make a prediction. Look at this example. Solve the system by graphing. Okay, we have to take the 9x minus 2y equals 7. Let's move the 9x over, and that will give us negative 2y equals negative 9x plus 7. Okay, divide by negative 2, and y equals 9/2 x minus 7/2. Then over here we have 4y equals negative 3x plus 14. We divide by 4. Negative 3/4 x. 14/4 is 7/2. Okay, I can see these have different slopes, so I know they're going to intersect. Okay, so I would go to negative 7/2, and then the rise is 9, the run is 2. Go to a positive 7/2. The run is 4, and the rise would be negative 3 in that case. So when I do that, I will come up with those 2 points. And now, notice, that's like 1, I don't know, 1 1/3, 1 1/2, okay, and then up about 2 1/2. So something like that. Now, the point is at 1 1/3, 2 1/2, I'm guesstimating on that. That's where you would try the 4/3 and 5/2, and you would put it into both of the equations and see, does that come out? Yes, yes. Then you have the right point. It might be, you know, instead of 1 1/3, it might be 1 1/4 or 1 1/2. And there are easier ways to do it, and you're not going to come up with those normally. But that's the example of it's between, I'm estimating it. Now I'm going to check that and see by putting that point that I think is the answer into 2 equations. Yes, yes, good, I got it. If you don't get yes, yes, you were close, but you didn't get the exact point. Well, now Laura is going to show us how to use the calculator to graph the lines and solve the systems of equations.
Welcome to today's Tech Corner. In the lesson, you've been learning about solving systems of equations by graphing. To do that, you've plotted the points for one line, connected them, and then plotted the points for the second line and seen where the two lines intersect. Well, as you can imagine, there's a quicker way to do that using your calculator, and that's what we're going to do in today's lesson. To start out, as always, let's check our settings. Remember, the most important thing to do is always to make sure our calculator is ready to show us the information that we want to see. Here's our mode screen. As always, we're going to be working with functions today, so make sure that our function key is highlighted and the rest of your settings should look just about like mine. Now we're going to take a look at our y equals screen. First of all, there should be no equations in our y equals screen because we're about to graph two different equations. And second of all, none of your plots should be highlighted. If you haven't used your calculator to graph since the last Tech Corner, you might have one or more of your stat plots highlighted. We need to make sure those get turned off before the lesson. So let's go to second stat plot for a little refresher course on how to turn off our stat plots. Here you'll see that all of mine are off. If one or more of yours says plot 1 on, let's just hit 4. And remember, here's the plots off command, and we press enter. It tells us that all of our stat plots are turned off, and we're ready to graph our equations. So here we go. On our y equals screen, let's enter our two equations. Our first equation for today is going to be 2x minus 19. This should be easy for you by now, but if not, once again, let's go through it. 2, and then we'll use our variable key up here, x minus 19. And there we go. We have 2x minus 19 in our first equation field. There we have y1. That's our first equation. Now we're arrowed down to our second equation. We're going to enter negative 3x minus 2 for our second equation. Once again, negative 3, and then our variable key, x minus 2. Now we have our two equations all ready to go, and your screen should look just like mine. Now remember, our zoom key, remember from the last lesson we used zoom stat, and that put our x values at 1962 to 2008. Well, you're probably not going to see the part of the line you want to see if you keep your zoom set at those parameters. So let's go ahead and hit 6, and we'll look at zoom standard. And sure enough, our two lines will graph. There's one of them. There's the other. So here we have our equation 2x minus 19. And here we have our equation negative 3x minus 2. Remember, you can break the lines apart. We have 2x minus 19 right here with the slope of 2 and a y-intercept. But wait, we can't see our y-intercept, can we? Because it's all the way down here. Because our y-axis values are going from negative 10 to 10. And kind of the same thing with our other equation. We have negative 3x minus 2. So we have a slope of negative 3. And you can see our y-intercept, but we can't see the place where the lines actually intersect. And that's going to be very important for this lesson, that we want to be able to see the intersection of the two lines. So let's zoom out so we can see the intersection. I'm going to go to zoom, and we'll just hit zoom out. And we'll place your cursor automatically at the origin at 0, 0. And if you press enter, it will simply zoom out on that spot. Let's just go ahead and do that. You could always move your cursor so it zooms out on a different spot if you want to see a certain area. But here we go. We'll just press enter. And now it's showing us a much wider view. And now, sure enough, we can see the place of intersection. Like we did in the previous Tech Corner, if you hit window, you can see where zoom out took us. And sure enough, there we go. X min is now negative 40 and X max is 40. Y min is negative 40, Y max is 40. And that's why we can see the point of intersection. We can also see the y-intercept for 2x minus 19 that we couldn't see before. Now we want to determine what the actual point of intersection is. One way of doing that is to simply trace the line and try to get as close as possible to where those two lines cross. Let's do that first and see what we come up with. By hitting trace right here, it'll put us on one of the lines, and we can use our arrow keys right and left to move up the line a little bit. And sure enough, there we have an approximation. It looks kind of like we're close to the intersection, but do we know if we're exactly on it? I mean, we have two numbers here. We have x equals 3.4 with a lot of decimal places after it. We have y equals negative 12.19 with some more decimal places there. but there is another way using your calculator that you can find a more accurate point of intersection. And this will be very helpful to you. Instead of maybe zooming in on the spot and trying to get close, you can simply ask your calculator, where do these two lines cross? And to do that, instead of hitting trace, we're going to hit second trace, just like this. And that will bring us to our calculate screen. And you'll see all these different options right here. Now, in your study in Algebra 1, you may use a few of these first ones, like minimum or maximum. They'll tell you the lowest point on a graph or the highest point on a graph. The one we're going to use today is number 5, intersect. You'll notice there are some other options on here. You probably won't get to these until pre-calculus or maybe even later in your study of math. So right now, let's just use number 5, intersect. So let's arrow down and press enter. And here your calculator is going to ask you, which two lines are we finding the intersection of? So here we go, first curve. It's a question. All right, let's arrow up to give our calculator a little bit better idea so we can see our cursor. And you'll see in the upper left-hand corner of the screen we have y1 equals 2x minus 19. Your calculator is telling you which line you're currently highlighting. All you have to do is press enter. Now it's going to ask you, what is your second curve? Or which is our second line? And here we have it. Negative 3x minus 2 is our second curve. And to select that, all we do is press enter. And now it's going to ask you to estimate, where do you think the approximate point of intersection is? And you can, if you want, go up a little bit and try to get as close as you can. Remember, this is about what we had before, 3.40 and negative 12.21. And now if you press enter, your calculator will calculate where your exact point of intersection is. And sure enough, there it is. X equals 3.4 and y equals negative 12.2. You'll notice both of those values are really close to the ones that we estimated, both when we were finding the point of intersection using the calculator and when we were tracing. But using the calculate intersect function on our calculator, we can get a more accurate point of intersection. Well, that's all we have for today, so I'll see you next time.